Good morning or afternoon. I don't know which it is when this is going to be played, but this is Sally Boysen, aka Sarah, my legal name, coming to you from look where I am, y'all. Do you see palm trees? Do you see the stairway up to the banquet room? Yes, I'm coming to you from the Radisson in Indialantic Beach. I thought it'd be very apropos to come and record my talk from the pool bar, which some of you know I spend a significant amount of time during CO3 when I'm not at meetings, of course. Then I'm typically at the pool bar with my margarita and French fries. And Ben, who is off today, unfortunately, we saw him yesterday, but I came down just to record the beginning of my talk, and I will integrate it with some other slides, etc., that I have at home. But I did want to start by telling you a story about a little girl's presentation. After I retired, because you know I'm old, yesterday was my birthday, and I'm old, and I was substitute teaching in an autism classroom. I found that many of the things that I did in terms of trying to get complex concepts across to the chimps really generalized quite well to kids with that were on the autism spectrum. But at any rate, a little girl in the regular classrooms named Dakota uh, wanted to do her science project about me. And so she even made me a lab coat. She got a long t-shirt, cut it down the middle, drew a pocket protector and some other things that she thought were sciency, and gave that to me. And I went over to the second grade classroom so I could hear her talk. And she began it this way. Dr. Sarah T. Boysen was born March 5th, 1949, and she is still alive today. And her talk went from then. I laugh so hard, and I laugh every time I think about that opening to her talk. So I thought I'd share that with you all too. Um, so what I'm planning to do is just step through a number of studies from the past, just to give you a flavor of what we were doing at the Chimp Center at Ohio State at the time. And then I want to show a few things that represent what I've been working on lately. I'm a collaborating investigator for the Center for Animal Welfare Science at Purdue, and I also have a project with scent dogs with two expert dog trainers in Milwaukee. So I've been working with them over the past few years. So I want to talk about those things towards the end of my talk. So let's get started with some slides. Okay, so this is the title of my talk. I don't know how many times in my so-called career, I actually had to count on my fingers how long I've been working with chimps. And if you go ahead and include the last 15 years when I was locked out of my lab at OSU, it's 48 years, long time. So it's not a monkey, it's an ape, and I'm her teacher slash mother slash, well, that's enough. Well, as many of you know, and again, I want to thank the talks that have preceded me. I did tell Bob I had to look up what an iconoclast was just to make sure he wasn't being derogatory, and I was pleased to learn that he kind of was, but that's all right. Much of our work has emphasized counting because at the time we weren't a low budget project, we are a no budget project. So I was working on an array of things, and we sent in an NSF grant, and they were interested in numerical competence. So by golly, numerical competence it was that we started to emphasize. And all of you are familiar with the legacy of Clever Hans. It haunts us still today. I think it's if 100 years from now people are still working, which I'm sure they will be, in comparative cognition, Clever Hans' concerns about social cueing will be with us even then. Well, let me talk to you just about the first couple of projects that we did on numerical competence, because that's what got things started. And at the time I had just 3 chimps. Sheba was 3. Kermit and Daryl had come from Yerkes Primate Center. They were 4. And I realized that again, there was very little literature. Tetsuro certainly knows, what was there about primate number skills in the literature, and it was very, very sparse indeed. But it seemed to me that, sort of going by the seat of my pants as a chimpanzee teacher, that they at least certainly had to have some understanding about one-to-one correspondence. So again, no budget. I got ice cube trays from home, and I had a big collection of empty wooden spools. So I taught the chimps to a simple one-to-one correspondence task. And the idea was, you've got to put 1 spool in each of the little cube areas of the ice cube tray. And when they were done with that, they got rewarded. Of course, they were also learning other things like sharing and turn taking, etc. So you've got, these chimps, 3 chimps running around, and you're trying to orchestrate, trying to build some beginning of complex concepts. But that's not how we started, with one-to-one correspondence. I knew they were going to eventually need to know there was 1 verbal label for a number. There was 1 thing that you could count at a time. All things could be counted, a whole host of things, but they really had to start with one-to-one correspondence. Now, initially, again, no budget. So it was lucky that my husband at the time, because I've had several, only drank chock full of nuts coffee. And so the lids were plain yellow. So I used those lids. And originally I had just I cut some round circles out of electrical tape. And so there'd be 2 dots on them. Let me move to the next slide and show you. And I thought that was going to be fine. And the idea was, if you look at this first panel, I put a gumdrop down, and the idea with that piece of electrical tape, I wanted them to just pick that middle lid with the piece of tape on it. And they acted like they couldn't even see it. They would pick a blank cap or top. And so I didn't understand what was going on. But at the time, I went to our favorite store, and which was, now I'm trying to think of it. Guys, where the electronic supply store. Oh, Radio Shack. That's it. Radio Shack. Yeah. And they had these round magnets, and they weren't very big or very thick, but they were kind of like washers. So I got a collection of those, and I glued those on instead. And it was so interesting because just that little bit of dimensionality added to that coffee can lid, and they began tracking it just beautifully. So initially, they were just getting trials with 1 thing. But I will tell you, for years, literally for years, when they would get that, when we were past this, though, I stopped doing it. But during this training time, I would pick up the gumdrop and put it on top of the magnet and say 1. And then they got to eat the gumdrop. Not an inconsequential event as far as I'm concerned, because at the end of the day, when the chimps had learned about numerical symbols, they had, if you will, come to hear the number label. They could see the visual array. They experienced, if you will, 3-ness, 5-ness. 5 gumdrops is way better than 1 gumdrop. So it was an all-around multimodal kind of experience to learn number symbols. But going back to the original training, once they were tracking that 1 gumdrop, then I added another lid with 2 magnets on it. Now they only had trials with 2 gumdrops. And again, every trial, I'd pick up a gumdrop, I'd put it on a magnet, I'd say 1, pick up the other one, say 2, and they would get to eat the gumdrops. And then we moved, of course, to adding 3. Oops, can you see that? Let me move this. And when I initially added the 2, they only had trials with 2 things. And then once they were, again, tracking and ignoring the 1, then I mixed the trials. And of course, that's when they really had to make the discrimination between 1 versus 2. And they were eventually successful. Well, except for Kermit. Okay. Kermit's an anomaly. I did this with Kermit for 5 years. Okay, not 5 months, not 5 weeks, 5 years. And it wasn't until we added a computer operated touch frame system that he learned numbers, and he learned them within 6 months. And it turns out he was measurably ADD. We did a comparison task with 2 neurologists at Children's Hospital looking at kids who had chronic hypoxia prior to open heart surgery. And it was discovered that many of these kids later had learning disabilities or showed evidence of learning disabilities when they got to school. So our collaborators came to us and said, we want a task that a 3-year-old can do. So we figured if we devised a simple task with the chimps, that a 3-year-old human child should be able to do it. We just didn't tell their parents we were going to compare their performance to chimpanzees. And that worked out quite well. But when we did the task with our chimps, Kermit showed all the classic attention deficit disorder concerns. But I knew that as his teacher anyway. And then having tried to work with him with numbers, it was very apparent. Well, let me move on. When we wanted to introduce Arabic numerals, I introduced them directly. If you look down here in the corner, I just took away the lid that had one magnet on it and substitute for the Arabic numerals. And again, we went through the trials systematically until they were responding correctly to 1, 2, or 3 gumdrops. And sure. Okay, my screen is frozen. There we go. Now, this phase, even though it's not a very good depiction, is a really, really critical part of the training that they had. Because what I'm describing for you are the only systematic training I did with numbers with the chimps. Okay, they had the labeling task we just saw. Now I wanted them to learn to decode a number. All right, now this is back in the day, and it was before personal computers. I think we had this kind of Tinker Toy one from Radio Shack, but we didn't have anything set up in the lab. So what I did is I set up a white background, and I took the chimps' number placards, and then I video recorded, a series of numbers that I would then replace, and I would put a number down, and then in my gut, I would kind of go, okay, how long do I need for Daryl to answer here? So I got to record it this long. Okay, that's good. All right. And the idea was for them to show me the use of numbers receptively. Now I want to take just a minute and talk about that, because we have a shared symbolic system with one another. I have a part of my brain, as you all do, probably in the left hemisphere, called Broca's area, that handles the complex capacity in many respects to produce verbal language and verbal symbols, right? But then in order to have a dialogue and have a conversation, there has to be someone else who can decode what I'm saying. And that's taken care of by another part of the brain called Wernicke's, all right? And both of those two things create a kind of symbolic space that allow us to do all kinds of things with symbolic representations. And I always envisioned this kind of bridge that grew between Broca's and Wernicke's, and I think literally there is, or there are many different kinds of pathways between those two. But the chimps don't come by all this regularly. First of all, they don't have verbal speech. And I knew from working at Dwayne Rumbaugh's lab that when we taught the chimps to respond to graphic symbol system, that is to pick a symbol on their touchscreen and label an orange, that if I then used the keyboard and I hit orange and they had an array of fruit in front of them, they might pick a banana or apple. They didn't have the same one-to-one relationship if someone else used the symbol. That had to be taught separately. So I remember that very distinctly when we began working with numbers, and I knew I wanted to train the chimps to the receptive use of numbers. That is, they've got to be able to produce, if you will, a label by touching one of the plastic placards with a number on it. So I'm going to label an array with a placard, but I've also got to be able to look at the number, which we saw very elegantly in Tetsuro's work as well, got to look at the number and decode it. Well, silly me, I first started using their candy arrays because we'd been doing that. Well, the chimps took one look at that and said, oh, I have to choose between 1 candy and 5. Well, I'll take 5. I don't care what's on the screen. I'm not paying any attention to the television anyway. So after a couple of weeks of complete failure at this task, and this is a good lesson for all of you who haven't learned this yet, you got to listen to your animals. They will tell you if you're, clever or smart enough, or you think about it hard enough, or you talk to enough people. They will tell you what you're doing wrong in your paradigm and what you have to fix so that they can be successful, because that's your job. So I realized, oh, I can't put those edibles in front of them. This was long before the quantity judgment work, but the same kind of phenomena was happening. So instead of having arrays of edibles, I brought the magnets back in, and they began acquiring the task just fine. Now, this is also from that first paper published, I think, in 1989, when most of you were probably not born, I recognize. And this is an idea I had because I wanted to try and see how could we have the chimps use their numbers in some, what I called a functional way, or a functional counting task. So we set up the system, and that stump is really not to scale. Believe me, it looks like a sequoia was drug into my lab. It wasn't that big, but there was a hiding spot behind the stump. And then over here on the left, this was a food bin attached to the front of one of the cages. And this was just a plastic wash bin. And this gave us 3 sites to hide things. Okay. So the idea that I thought I could teach the chimps was the following. I'm going to hide some oranges in these 3 sites, among these 3 sites. You might encounter nothing. You might find 1, you might find 2 somewhere. Okay, small numbers to start with, but you all know about the tasks that the chimps have learned. They learned to match the magnets, to get gumdrops. They learned to decode the numbers from the television and pick the magnets again. Those are the only tasks I taught the chimps. Okay, this is really important to remember. And imagine also, we're talking about, I'm going to take a 4-year-old chimp in this case with Sheba to start with. She's running loose, a 4-year-old. Think of your own 4-year-olds. And I took her by the hand to start with, and she didn't see me hide the things. So I said, oh, look here. Oh, look, there's an orange, Sheba. And then we walked over to where the food bin is over here. Oh, there's no oranges here. Oh, let's go over here. Look, Sheba, there's a couple oranges. Then we came back here and sat down. And I literally asked her verbally, because chimps really, they can really grasp the context of what you're talking about. How many did you see? And she said 3. When I say she said 3, that is, she pointed to the placard with 3. Okay, that was a little surprising to me. We did a few more trials, and she was something like 88% correct. Okay, now this makes you very nervous, all right? Because she's moving in time and space, she's accumulating a number of items, and then she's summing them and giving me the answer. And she'd never been taught such a thing. So at the time, I knew enough to request her with great protestation to go back in her cage. I drove to campus. I got Dr. Bernson, my collaborator, with whom I could not have done any of this stuff without. And I said, you got to come to the lab because Sheba's counting and adding, and we need to run double-blind trials. And so we did. And she was, again, like 88 to 89% correct performance on double-blind trials. She, from the work that we had done in those 2, the productive and receptive tasks with counting, had come this emergent skill. It was amazing. And we had a conference scheduled, or I had a symposium scheduled for MPA, and I thought, how am I going to explain this? We haven't even presented any of the original training work, and now she's doing things that she shouldn't be able to do. But I've got a few more weeks. So yeah, there's the big surprise. She already knew how to do this, right? So I thought, well, maybe I can do another task, and maybe I can teach them of this task, and I'll have enough data to present at the conference, and it'll be, interesting. So this time, instead of putting actual objects out in the locations, I put the Arabic numerals instead, so that she might encounter a number 2, maybe the number 0, because we'd already added 0 and 4 and a couple other numbers to their repertoire. But she might encounter 0, and she might encounter 2 in one of the other sites, and then again has to come back to where the placards are placed and give me the total. Well, again, we ran a few trials. Oh my gosh, she was doing that also. Okay, now she's summing number representations. Who taught her that? How can this be? It made no sense. And Sheba, she already knew what was going to happen, and that is back in the cage you go. I drive to campus, I get Gary, we come back to the lab, we run double-blind trials, and she succeeds at the task. Well, now I was really in a pickle because I had to somehow have something to say at MPA, where I'd organize a symposium with all the famous people that worked in counting, and I had to be able to explain what was happening. So I was forced to go to the children's literature and read up about early counting in children. And as it turns out, children acquire spontaneous addition algorithms around age 3, even before they have any formal training in arithmetic. So it's part of those emergent skills with counting that you don't know is happening. That's what human minds do. That's what chimpanzee minds do. They have the capacity to put information together in novel and unique ways when the task demands or the ecological demands for them, whatever, present themselves, they can solve the problem. And that's exactly what was happening here. Somehow, some way, that synergism of the multimodal presentation of those arrays, the experience of eating more, there was even one time when I have it on film, Sheba was counted an array of like 6 gumdrops, 8 3, and then tagged the last 3 and touched the number 3. And I said to her, "What are you doing? Teaching yourself subtraction?" And in fact, that's exactly the kinds of things that happen with those minds. So it was an amazing thing to see, and was one of the most exciting things that happened during those early years. Now, keep in mind, we're not going to talk about everything because I've been working with chimps for 48 years. And so I'll go to the quantity judgment task that Mike Barron so artfully has elaborated on in his career. And I have to thank you, Mike, for those beautiful, beautiful, elegant studies that you've been doing, especially that last one, the hybrid study. But let me tell you how this first started. I wasn't interested in the quantity judgment task per se. What I was hoping to do with it was explore social cognition. And the original idea for presenting the task was to see if I could teach the chimps this sharing task, okay? Then eventually put up a partition between the 2 animals and see if the chimp who had the opportunity to make a choice would always cheat and make sure they got the most. That was the basic idea behind doing the task to begin with. So Mike talked about it. I had 2 chimps participate. One chimp was designated as having all the power. They were the selecting chimps, the selector. And 2 arrays of candy would be presented between the 2 of them. And then we started with Sarah and Sheba just because I thought Sarah would be successful. And Sheba also was very flexible, could be outside the cages, and it just made for a more optimal setup to start with. So we have 2 dishes of candy available in different amounts. We started with 1 versus 2, okay? And Sarah was the one who was allowed to pick, and she picked, 2, okay? And then Sheba got 2 candies, and Sarah got 1, and we went along like that, and Sarah didn't show any difference. She kept picking 2 no matter what happened. This went on for about 30 trials, and Sarah's getting increasingly, well, Tessero, you know her, she could get quite testy, and she was not happy about what was happening. So I decided, all right, I'm going to up the ante. We're going to now go from 1 to 4. Didn't make a difference. 1 to 6 candies did not make a difference. No, She persisted at picking the larger array no matter what. Well, now again, you have to let your animals tell you something about what must be going on. And I also remember, and I think is attributed to B.F. Skinner, and he said, if you find something interesting, drop everything else and study that. So I'm now decided we're not going to do that social cognition task because I'm going to figure out what is happening here. Why can't two of the most highly trained chimpanzees understand what's happening and just do this reverse contingency task? It was the weirdest thing. I mean, here you can see in testing with Bobby and Sheba, Bobby's looking away. He's not paying attention. All he has to do is stick his hand out and he's going to get a handful of gumdrops. And poor Sheba is going to lament when she gets the two on the other side. This persisted over and over and over, and we expanded to other chimps. They performed exactly the same. As it turns out, they really could not inhibit choosing the larger candy array. More, if you think about it, in many cases, more is a better choice, and their persistence at that larger array continued. And I will tell you a little bit in a minute when we switched the candy arrays for rocks. But my idea, the plan was to switch to numerals. All right, now let's subsume some of the characteristics of the candy arrays into numerical representations. Just ignore that phone ringing in the background. And almost from the very first trial, it was remarkable. They immediately responded by choosing the smaller numeral. So that meant they got the array represented by the larger remaining numeral, and this persisted. And so if you look at the data that we already saw when I think Mike presented these as well, and I used to tell different groups that I showed these data to, and once I was showing some Boy Scouts who are about 10 years old, and I said, boys, you don't need to know anything about statistics or graphs. Just think of this: tall bars good, short bars bad. Okay, so for the first session on numerals, strong performance. Go to candy 2 days in a row, no, bad performance. Back to numerals, great, candy, crappy, numerals. And the most interesting thing was that their supposed acquisition when using numerals did not extend to going back to candies. They would still persist at choosing the larger array. So again, I'm thinking about this, and Dr. Berntsen and I differed in our thinking about this. He thought it was the general greater hedonic value of that candy sitting right in front of you. You just can't inhibit, and chimps aren't that great at self-control, and either am I, so I could really understand that. But I can pick out the larger piece of cheesecake on a buffet table without batting an eye. But the chimps, if you switch to rock arrays, I mean, I just went out in the driveway of our lab and got clumps of big gravel and made up rock arrays. They treated the rock arrays exactly like the candy. That's when I knew that I was right and Gary was wrong. It's not the hedonic value. It's not that it's edibles. It's the perceptual display and the perceptual array and the perceptual awareness that this is more, and it represents more. So even if there were rock arrays and they could not pick the array that had 2 rocks, and then they would have received 5 rocks as a remainder. They could not make that choice. And I have been so pleased that Mike has been able to go beyond this and do so many beautiful studies to look at this phenomena. And I used to make the joke that I wanted to call it the Boysen effect, but that I had 2 ex-husbands would say there already is such a thing as a Boysen effect. And with that, I want to, again, because we did lots of studies. We looked at scale models. We looked at I don't know, just we have many papers of lots of things that we did. But I wanted to be able to have some time to talk about the things that I've been working with the last few years. I had trouble retiring, shall we say. It didn't sit well with me. I had too many too active a mind, and the old tape recorder going in the mind. And I did then eventually hook up with my old friend Barb Bell, who was friends with Kathy Hatch, who is a trainer of other trainers who teach scent dogs to work. And I began working with them about 3 or 4 years ago. And as it should be clear, well, maybe not clear, they teach dogs to identify scents, etc. And the idea behind this Midwest Medical Dogs, at least more recently, was the idea that we might be able to teach dogs to detect hospital-acquired disease hotspots, and then allow hospitals and nursing homes where these kinds of things happen to do further eradication in order to get rid of the bacteria. And the bacterium that we're talking about right now is C. diff. We're currently working with 2, 4, 6, 7 dogs, 3 Labrador retrievers that belong to Kathy Hatch, and a field spaniel, border collie, a Danish Swedish farm dog, and an Australian cattle dog that all belong to Barb. So I go up to Milwaukee periodically to do dog testing, and we keep in communication on a very regular basis about how the dogs are proceeding. Now, this was the setup when I first went up to train or to record and get some systematic experimental trials in the can. And I was very surprised that this linear presentation, and I said to Barb, you know, an experimental psychologist wouldn't do this. We would have it horizontal and let the dog go out, and but she said this is how the police do it, and so that's how they do it, and so that's how we do it. All right, and they use those odor cups along there. There's 5 of them. They're 5 feet apart, and they use anise for training. So if you look inside this odor cup, there's a screen over it, and there are Q-tips soaked with anise, and that's what they use. We use for the odorant. Let me show you some video. They're very fast because the dogs are very quick. And I want you to try and listen carefully because there are 2 people off screen. The trainer with the dog is wearing a mask and a blindfold, and the 2 people off camera, one it knows where the bait is hidden, but their eyes are averted. No, they are looking, and the other person will report what choice the dog has made. So let's go ahead and look at these. I've got 3 instances to look at. This is Cousteau, a Black Labrador, obviously. So in case you didn't hear it, someone said 4, and then the other person said, yes, that's right. So that's how everybody shares information, takes good coordination. Let me stop this for a minute. One thing that's interesting, I've been learning so much about scent work and the particular breeds that are being used. And one of the reasons that they use Labrador retrievers with helping the blind is that they tend to do a very, very linear search. And so I'm sure that's part of why the training regimen has worked out the way it has. But you'll see in the, not this one, but the next dog or the dog after this one, after the next one, who's a border collie, she already shows you she wants to try and herd anybody that's in the room. And for me, I've been fascinated by the differences in breed, where, you know, dogs breed very true to the kinds of, you know, we have stereotypes of how dogs behave as a specific breed, and there's a reason for those stereotypes. But let me go ahead with Nellie so I can get through enough material to talk at the end. Here comes Nellie. Beautiful, beautiful field spaniel. She's kind of reddish. I don't know how she does that, but she must already gather the air from the beginning. So they're always rewarded over the odorant cup, again, to try and reinforce that relationship between the anise and the reward. And here's Pippin, who's a border collie. This dog was imported from Wales. Big bucks. Oh, let's herd these people over here. No, maybe not. Okay. So see, she points. Pippin points to where the thing is hidden. Well, what were we to make of all of this? Well, we partnered about maybe 2.5, maybe almost 3 years with Dr. Paulo Tiedemann at Texas Tech, who is a forensic analytic chemist. And we approached them about trying to pull out the odorant from C. diff. Now, C. diff is a bacteria that it's everywhere, but it is especially problematic in hospitals and nursing homes where people who are immune compromised or older are going to be more susceptible to an invasion of C. diff. It produces terrible, terrible symptoms of diarrhea, stomach cramping, dehydration, and it can be fatal. So it's a very, very difficult problem. And part of the problem is that it throws spores, and then those spores lay dormant for a long time and have not been eradicated. And so you have the persistence of it. So our idea was, can they pull out the odorant so we have something that has no biohazard qualities to it, but we can use it to train the dogs and eventually then be able to go in an applied setting and have the dogs find the hot spot in a hospital setting and do further eradication. Now, of course, just like everybody, the pandemic kind of held everything up. So for about 1.5 years, they weren't able to make very much progress until about 2 months ago. We got an email out of the blue, and Paola told us that yes, they had managed to separate out the odorant, and they're still in the process of working out the duration of the scent remaining in the kind of container that they will be able to send to us. So we are literally like just weeks away from getting the odorant for the first time, and I'm very excited about the possibility of the animal. I know the dogs are going to pick it up very, very quickly, and it's going to be an exciting time. Oh, just a little bit, very little bit. I think I've already told you about C. diff, Clostridium difficile. It's a hospital-acquired infection, very virulent, difficult to eradicate, as I said. And recently, just a few weeks ago, Paula's lab, also her graduate student who's working on this project, produced a beautiful, exciting poster talking about this novel canine detection application. And this is one of the things, again, for you younger investigators and early career folks. I think anytime we can get real animal behavior, capitalizing on the capacities of animals out so that the public is aware of it, it's always a good thing. One of the remarkable things about Tetsuro and his work is that he was just fabulous at marketing. You've got to toot your own horn a lot of times. So you all should learn who the communication person is at your university or college. Go talk to them, have a personal relationship. And when you have information you can share, I mean, how many of you have put out a press release? Probably not a lot of you, but there's no reason why you shouldn't. Why do you think we always hear about research coming out of Harvard or Columbia or Yale? Because those people are reaching out into the community, and it's really what we need to be doing more and more as the concerns for our field of comparative cognition increase. Well, let me quickly go to the second place where I'm involved, and that is the Center for Animal Welfare Science at Purdue. It's directed by Dr. Candace Croney. I happened to be on Candace's dissertation committee some years ago when she was at Penn State. And one of the good things about, I guess, living long enough and having students who are successful is that maybe when you're 70, they'll hire you to be on their grant, and you edit and rewrite graduate student and postdoc papers, or generate papers from those studies that we all have that are in folders sitting on our shelf that we intend to get to. Well, that's me. But it's been very exciting and very interesting. The Center for Animal Welfare, under Candace's guidance, has really looked at a whole host of things, a whole host of questions about what is animal welfare. But one of the things that I'm most proud of, and it also involves the collaboration with Candace and one of my former graduate students, who became an extremely excellent applied animal behaviorist, is that they have gotten into, they've wormed their way into 150 Amish commercial breeding facilities, some of which could have been described as the term we know as puppy mills. Well, we now work with 150 commercial breeders, and they have the idea is to bring their infrastructure up to USDA standards, so that that the animals are better cared for in general. They have a better environment, and they also have been focusing on early socialization of puppies, so that we don't have as many. If they do sell to some commercial operation, like, I don't know, I don't want to name some company, but let's call it, Pets Forever, that you don't get dog or puppies that are ill or poorly socialized, and that the impact of that early rearing has been a very positive thing. So that's very exciting to me. We're in 7 states now. They also have the first program ever in the world of certified canine care, again, to improve the lives of those animals. We also did a paper, and it was shepherded through by Mike Barron, with a pig using a joystick with the task, with software from Bill Hopkins, which was great at the time. And you can't imagine the media and public reaction to the publication of this paper. I think it has had more views than anything else that Frontiers in Science published last year at all. So the public is still hungry for new and exciting ideas about what animals are capable of. So keep that in mind. If you think your snake research is too dull for somebody, you're wrong. You don't know who you're going to reach. Part of what drove me to do science was a picture of Eugenia Clark dissecting shark embryos. She was on the deck of a ship dissecting shark embryos out of a shark, and I never forgot that picture. Here was this woman doing this cool stuff in science, and it had a tremendous impact on me. So keep that in mind. Get your stuff out there. Let people know about it. Let kids know about it. All right, now quickly, because I'm running out of time, I know, I wanted to share some new and exciting things with you, and I would say, imagine my surprise. I've been retired for 8 years. My lab was closed by force by my university, so that one of our multi-billionaire board of trustees at the university, could build condos on the land where my chimp lab was. So 15 years has gone by, and I've not been able to do chimp work, really, because it was pretty traumatic, as you might imagine. But recently, well, about 2.5 months ago, I got an email, very unexpectedly, from the program director of cognitive neurosciences at NSF. And he wrote something like this: "Dear Sally, I've always respected your beautiful research on chimpanzee cognition. I wonder if there's any way that NSF can support further work. Well, if you are interested, get in touch with me." Well, okay, yeah. And now is where I would have presented some lovely slides from Bill Hopkins' lab, because it seems now that I will be collaborating with Bill at the Michael Keeling Animal Research Facility affiliated with MD Anderson, which is located outside of Austin, Texas. So after 8 years of retirement and 15 years of not having a lab, I'm being lured back into chimpanzee and monkey cognition work. And it's very exciting. One of the first things that NSF wants us to do is to offer a workshop on ape and monkey cognition. So that we'll begin planning for that, right, Bill, pretty soon. And yeah, well, it looks like it. It seems to me they're pretty interested in giving us money to do that. And we'll also be applying for funding for a whole range of projects, some of which will take advantage of this incredible collection of brain scans across the great apes that Bill has, and just even more remarkable software that allows you to do extraordinary manipulations with those all those data available on those scans. So it looks like I'm back. And with that, I guess we could open up for questions. I can't hear anybody.
Woo!
That's because we were muted.
Oh, Candace. Oh my goodness. Hi.